Hello, everyone. Today we are here to talk about cloning Dolly the sheep. We all know famous Dolly the sheep, but before we actually saw the living, breathing proof of concept, most people didn't even know that it is possible. And a few years later, they copied cat. They actually called her CC or copycat, then a horse, and nowadays, if your pet that you really loved just died, and you have a spare $100,000, you can have it back. So, but how about humans? Why don't we clone the humans? Well, there are several reasons for that. One is commercial, because at least officially there is no commercial interest in doing it. Of course, there are legal and ethical issues. And most of all, there are scientific countermeasures, scientific obstacles. Most scientists will agree that it's very difficult to clone a primate. But can we be really sure that there is no living human clone walking around us? But how about mobile contactless payments? Well, I think we can safely agree that based solely on the market growth predictions, the fraudsters definitely have commercial reasons to do it. And of course, this is illegal and unethical to steal people's money, but I don't think the fraudsters have such kind of morality. So we actually have left the technical countermeasures left, and there are a lot of them. So there is tokenization, there is cloud secure element, device provisioning, fraud detection, and so on. But can we be really sure that these countermeasures work as expected and they can withstand the incoming threats? Well, we're about to find out in a few minutes, but first, we'll need a short introduction on this technology. So who of you knows what is host card emulation? Okay, who pays by the phone, by contactless payments? Okay, maybe someone is implementing it from a bank. Oh, yeah, great. But I think a short introduction will not hurt. We'll get back about 10 years when the first mobile contactless payments were born. The idea was to make them as secure as the plastic cards, to embed a secure element, hardware, which will keep all the card data and all the services which are run in the applet Java card inside this hardware secure element, and it connects directly to the NFC antenna, so the mobile OS and application do not have access to the card data. But already then, everybody knew that the mobile contactless payments are the future, so everybody wants to control it. And there were very difficult arrangements between banks and mobile operators who owned these secure elements on the SIM cards. And well, actually, it also was very difficult and painful to make it work. I, for example, have still such SIM card there, but I can't use it because it requires a special firmware from my operator. So when Google introduced the first Google Wallet in 2011, it was based on the Galaxy Nexus embedded secure element hardware. The mobile operators already had their own idea how to rule the world. They created ISIS. Yes, it was called ISIS Wallet, actually. And they deliberately blocked Google Wallet from their mobile phones because it used the secure element hardware. So Google decided to go in other way without the secure hardware. Of course, the ISIS had to change its name, and a few years later was acquired by Google. But the spark of the revolution Google initiated couldn't be stopped anymore. It was called Host Card Emulation, introduced in Android 4.4. There is no more need for this hardware troublesome secure element. Everything is moved to the cloud, and the software emulates the card. So everyone is happy. So how does it work? Well, actually, seeing is believing, so I will show you a live demo, I hope. I will try to pay with it. I have the contactless terminal here, over there. Okay, and I have a phone. Yeah, okay. Hopefully, when I close the phone, wait a second. Okay. And the transaction is accepted. Sorry, it's in Polish. I couldn't change the terminal language to English. So I just put the phone close to the payment terminal, and it works. Okay, let's get back to the slides. Okay, but you know how it works from user perspective, but if you are a bank, how would you integrate it into your own mobile application? Well, you could do it by yourself, but it would be very painful and costly and long time certification process. So there are many external libraries that you can include into your mobile applications. Both Visa and MasterCard have their own SDKs, but there are several other products that integrate HCE library for you. And there's no clear market winner. There are many of them. So how does this look from the users, from the integrator's perspective? Well, this is a fragment of the real documentation. It shows that the encryption keys are stored in a secure environment somewhere in the cloud, hidden between two firewalls and reverse proxy. And another fragment of the documentation for the developer is that you actually need to care only about the SDK API to this external library. And this external library is showed like a separate entity, and it's actually called the same like the applet running in the secure element hardware, and there is secure element in the cloud. So this is the reality that the mobile developer is faced to. And when I talked to the guys, they didn't believe that it's possible to clone this card. While both Visa and MasterCard knew about this possibility, it was somewhere lost in the translation, I think. So that's why I decided to provide a working proof of concept that it is possible. And that's where my research starts. My name is Slawomir Jasek, or Sławek Jasek, by the way. I enjoy AppSec for several years now, and the more I moved to the research recently, the more I enjoy it. So enough for the introductions. Let's cut to the chase. How do we actually steal the money? So I'd like you to imagine that you are a group of thieves which are focused on this new lucrative target, the money in the phone. So how do you steal the money? Well, the obvious idea is to steal the phone, right? Double jackpot. We have the phone and we can pay with it. But think of it. If you would lose your smartphone, think of it. If you would lose your smartphone, then how many seconds exactly would you know that you are offline? Well, of course, you would immediately report it and cancel all the cards as soon as you will find a way to contact your bank without the phone. But I don't think it's really a risk, and it's also not very common for the plastic cards. So how about NFC? Well, we know there are mobile applications that can read NFC data from the card, right? So I have such a mobile application here, NFC card reader. So we'll try to read the data from this card. Okay. Okay, so I have this NFC card reader. I will try to read from this card, but it doesn't work. Well, why does it not work? Well, the screen has to be on. Okay, now I can read it. So it's not possible to do it without the user's without the user's consent. That's, for example, through his pocket, right? The screen has to be on. And but even if the screen is on, well, I could read the card data. So I have the card data and expiration date. This is actually my real card data. Okay, now tell me, how many of you have made a picture of it? Well, okay, I would do it. This is a hacker's component, right? I need to tell you that unfortunately, even if you made a picture of it, you won't be able to make online payments with it. I will tell you in a moment why. You may be able to create so-called track 2 of Maxstripe. There are mobile applications to which you can upload this data, and they will work as NFC to the NFC compatible terminal, which supports Maxstripe via NFC. So it might be possible. I wasn't able to do it, but if you do it, please don't steal my money. Let's do the research together, right? So why you can't use this card number for online payments? Well, there is so-called tokenization. So the real card number is changed into a random one. Every time you enroll a new device, you get a new random number. It usually stays for the whole life of this device, but if you enroll another device, you get another random number, and they have limited domain use. I mean, you can't use them for online payment, only for the contactless payments. So we have this card number, but it's not enough to make the contactless payments. Why exactly? How exactly do these contactless payments work? Well, besides this number of the card, you need a cryptographic key, which is then used to make EMV transactions. So what we are after is actually this key. So how do we steal this key? Well, one of the ideas would be to steal it in transit when it's transferred to this mobile application, but that's quite difficult. Usually the architecture is complicated, involves a lot of servers, and quite often Google Cloud push. So in most cases I saw, there is proper certificate pinning, and also very often there's a second layer encryption. So you have sometimes there is a proprietary protocol. Of course, there may be vulnerabilities in it. I saw a lot of improper certificate pinning implementations. I can talk hours what you can do after decoding the proprietary encryption. But as long as it is very exciting for a pen tester, I don't think it could be exploited in the wild. Other ideas how to steal this key? Well, it's stored in user space, so maybe we could somehow get it from the phone. Well, one of the ideas would be to have malware on this phone. A typical banking malware works as an overlay which steals users' data. It shows a fake login screen or something, can intercept SMSs, but the typical malware, the most common one, doesn't have access to the user's data stored in the application's private folder. So you can't have this access to this key. So how can we access this key data? Well, you need a root. I suppose most of you know what it means. Root gives you the bare-bone access to the file system, all the data you need to know. Root is gold. So how do we get root? Well, there are already frameworks and tools which aggregate many various exploits. They are able to abuse Android vulnerabilities to get the root credentials, and there are already multiple malware instances that are able to root the phones. And there's getting more and more of them. So if we were able to make this root malware into the user's phone, we would be able to get this data. But the data is encrypted. Well, of course it is encrypted. How couldn't it be? So how do we decrypt this key? Well, this is Android, right? So we can take the binary, decompile it, and understand what's going on, right? Not so easy. They use really good obfuscation in most cases. Well, of course, there are the obfuscators, and of course, it is possible to reverse everything. But if you were an attacker, you would need to do it for every single application, repeat the steps. And it's really difficult and time-consuming. So I noticed that creators of such security mechanisms, they tend to imagine that when attacker sees such safeguard, he will take his simple tool, like machete, and he will fight for this. But what if there was another way around this security mechanism? So let's actually think how this encryption works. I will show you once again how the payment is done. You just take up your phone, press it, and it's done. So you don't need to unlock this phone. Well, sometimes you need to unlock, but in most cases, no. And there is also a business requirement that it should work offline. So if your phone is not online, you should be able to make payments, at least a few of them. So how does the encryption can work? Well, the encryption key has to be somehow stored on the phone, or maybe hard-coded into the mobile application, or combined. There is actually no other way, I think, right? So you probably have an idea how to clone this. So we'll take another device, we will install the same mobile application, and we will copy all the data. So it should work, right? But it doesn't. Why? Well, there is another countermeasure. They call it device provisioning. So only the specific device can decrypt these keys. So how does this work? Well, probably the encryption key has another element in it, something device specific. So what if we took the same device with the same hardware model, and we could even change the IMEI number. And then compute the data. What would happen? Well, it turns out that it works in most cases. And in most cases, you need to copy also other users' data, not just the data of this mobile application. But I don't think it's really practical to attack on a mass scale. So if an attacker had to clone, buy the same device, physical device for every user he wants to attack, the return of investment in this attack won't be very satisfying, right? So we need to find out an idea how to do it on a different device. let's take a look what exactly device characteristics are possible to take from the device. Well, there are several of them, but many of them are not suitable for this use. Because, for example, OS version can change in time, so your application would stop to work if user upgrades. Many characteristics are very troublesome or impossible to get from the phone because of privacy matters, or non-standard implementations. Some of them require special privileges. For example, this one requires read phone state, and when the user installs it and sees that the mobile application wants to make phone calls, well, for most banking applications, it's not a problem. They already have this privilege, but for many, it may be a problem. So most commonly used are Android ID, the ID which your device gets upon registration to Google, and some of the SDKs I noticed they try to use device ID, but they are moving towards using less characteristics for this to be less troublesome for the permissions. So can we spoof this on another device? Well, yes, we can, using, for example, Xposed Framework, which works between the mobile application and the OS. And well, on the standard device, when the mobile application asks the OS about an identifier, it gets it straight from the OS. But on the where you have Xposed Framework installed, and you have a specific module that can change the specific ID, well, it can ask, it intercepts this call, and it can ask the OS, but doesn't have to, and returns a different one, the spoofed one. So in this way, using the Xposed framework, we can spoof the original device without having the same hardware, and in this way, this attack will work. But of course, it all requires root. And of course, these applications have root detection. But tell me, how many of you have rooted the phone? Yeah, a lot of you. And how many of you had to hide this from various applications, like Pokemon Go, for example, or banking applications? So we know that root and root hiding is some kind of cat and mouse game, right? So if you have ultimate access to the OS, you can always hide from the root seekers, right? Root detection. And most of all, the root detection works mostly for the most popular routing methods, and malware could use something non-standard, which is not detectable. So, for example, Android Pay uses Google's own safety net to detect root, and it's quite good, but can be, of course, bypassed. And this is a decompiled fragment of the safety net root detection, how exactly it searches for the super user binary. So in order to bypass this, I will use a very complicated and sophisticated attack. Just a second, I will connect to the device. Okay. Okay, so now I'm connecting to this device. ADB shell. So I will connect via remote ADB, but let's imagine that I have malware with root, right? So instead of using SU, my method is to use your initials. So in my case, this is SJ, and I have root now. So, and it's not detected by the safety net. So I could copy the relevant user data, this is from this phone. I will just need to, and the backup is made. We'll talk about the script in a moment. Okay, so now I can disconnect and get this data. Okay, so yeah. So I have the data from this phone, and I have another phone. This is the attacker's one, obviously. And on this phone, I have also Android Pay installed. Let me switch to the camera again. Okay. Okay. So there is also Android Pay installed, but when I try to run it, it's not been initiated yet. So when I want to read the card, for example, using card reader, it will show you that it's not yet active, right? So set up Android Pay, I don't have the card data. So now I will connect remotely to this device, the attacker's one. And I will try to restore it. Also use my initials to get root. And I have another script to restore this. Okay, it restores. And I will need to reboot this phone. I do not need it anymore. I will try to make a payment with it. Okay. Let's try a moment of truth. Let's try again. It wants me to insert the card, but how do I insert this card? It was declined because of other reasons. Let's try again. Okay. And the transaction is accepted. So when I check using this card reader, the card data, I can get exactly the same card number to confirm that this is the clone data. Come on. Maybe it's because of the rubber. Okay. So I have also the card, can read the card reader from it, and it is exactly the same card. I have just cloned the card data from one Android phone, from this one, the victim one, to the other one. So the demo worked, hopefully. And you're probably interested what's the cloning script. Well, it's not rocket surgery. It's based on simple commands. I used tar. You probably also know change owner. This one is probably the least known. This is the one to repair the SI Linux permissions. And I actually, I promised not to disclose the scripts, but I think you deserve for them. So we'll make a deal that I will show them for a second, and we'll cut it up later. So if you're ready, here it goes. You had your chances. So another one script to restore this tar data. Well, you saw it, right? Yeah. Okay. Well, there is one secret ingredient, though, for Android Pay. You need exactly the same OS version and exactly the same Google Services version for this to work. But it's doable. Right. So this proof of concept was done on a single low-value transaction, and it was actually made from the same network and on the same terminal. So I strongly believe that Google has FDS behavioral analysis that do not allow you to just clone all the user's data to other phone without any actual consequences. I mean, without they knowing it. That, for example, two exactly the same phones appear in various regions. And of course, banks have also their own fraud detection systems. And most of all, they knew that this could happen. So they store only a few keys on the device, and they are single-use keys or limited-use keys. So we can make only a few transactions, and these transactions are below the flow limit, so-called. So what could go wrong? Well, then you need the keys to replenish. But how does this work? Well, actually, in order to get the keys, the replenished keys, it's mostly also complicated. Let's, for simplicity's sake, that the key consists of two parts. One is from the server, from the banking server, and another one is usually pushed through the Google Cloud messaging. So actually, this part we already have. So we can successfully impersonate the real device to the banking server, and banking server cannot determine who is contacting him. We can also cut off the original user and request proper API call to get the replenished value. And in many cases, it is enough, just enough. You get the new values just by simple JSON REST API request. But in most cases, you also need the Google push. So how do you intercept Google push that was intended to another device? Well, of course, you could, if you have full control over this device, you can intercept it on the victim's device. But it would be more interesting to reroute it somehow. So how do we do it? Well, we actually already done that by cloning Android Pay. I cloned all the users' data, on the relevant users' data, so that both devices have the same Android ID, the same keys, and so on, and they are visible in Google services as the same device. So I made a test push, and while both devices were online, sometimes both of them received the push, sometimes only my spoofed one. And of course, when I disconnected the original device, I always received this push. So in this way, I am able to make multiple transactions because I can renew these keys. But we are still have limits of the number of transactions. So the transactions are actually the low value ones, right? So let's talk about this floor limit. So the transactions which are above the specified amount, that depends on the country, they need additional authorization. In most cases, you need to enter the PIN on the terminal. But how do you set up this PIN? Well, it turns out that as a result of a business requirement, in many applications, the host card emulation card enrollment needs to go through the whole process needs to go through the mobile application. So you get the new card and you set up the PIN in the mobile application. So of course, if I have a remote malware on this device, I could intercept this PIN, or I could trick a user, for example, to you need to change this PIN overlay. So I would have also this PIN. But there is another very interesting feature. It's called CDCVM. So in order to understand it, let's see a movie. I will need a voice for that. Okay.
Voor bedragen boven de €25 moet u op uw smartphone uw ING mobiel betalen 4-cijferige pincode invoeren.
So where do you enter the PIN? Well, on the phone, right? But how does it work? It's called CDCVM, Consumer Device Cardholder Verification Method. So when both the payment terminal and the device support this method of consumer verification, then the terminal says the cardholder, let's start the cardholder verification. This happens on the user's device. It might be entering a PIN, it might be some biometrics or various other means. And the device sends to the terminal that it is verified. So what if we had malware on this device? Well, of course, we could intercept also this PIN, but in this way, we could make more transactions on higher volumes. But actually, not many applications support CDCVM. Well, they are thinking of it, but they say that the terminals do not support it. They are not in very much hurry, and minority of applications supports the CDCVM. So what if the application doesn't support CDCVM? Is it fail-safe? Can we attack it somehow? Well, the application doesn't support CDCVM, but it has a HCE library which supports it. So the library has API names which cannot be obfuscated because this is API SDK. So these are, for example, API names, set CVM verification mode and Boolean value to true. So what if we took an application which doesn't support this user authorization and we added this to this application and set it to true? Well, in this way, our patched application would tell the terminal that it supports it, and we could tell the terminal that the user is verified, so the terminal will not ask for the PIN for the transactions over this floor limit. So this is where my results, my research goes to the edge. I mean, at this specific attack scenario, what I succeeded, I think, is that the terminal did not ask for the PIN. In unpatched application, it did ask. So this is the success part, but the failure part is that the transaction was declined. Maybe because the card was faked in this case. I couldn't do it on real card. And it's not really easy to repeat this attack because most of these applications have really good integrity protections. So it's not really easy to pass them. But when I asked the card processing guys in this specific bank, they told me that they are not aware of any security measure that could stop me from doing this. Maybe they didn't know of something. Maybe this specific card, for example, was set up to require online PIN. I don't know, but probably if I were a bank, I would like to know how my system would react to such kind of attack. And it's definitely worth digging deeper. So, of course, besides Android Pay, we tested multiple other applications, and most banks are thinking of implementing it, if not already implemented. We have made a living, breathing proof of concept for 8 applications which use 7 different libraries, and others we can estimate based on the libraries they use. It's not really easy to test it, because in order to test it, you need a real bank account and a card. And it's not really easy to get account number, for example, in Australia when I live in Europe. So it's still something to explore further, but we were able to clone all the tested applications, and I think it is possible to do it for every possible instance. So a short summary, well, without going into much of the details, the easiest application didn't even have a root detection and really simple device checks, which even didn't require Xposed. And the replenish push didn't go through GCM, so it was a really fat target for the predator. And another one did check a lot of device characteristics and had really good root detection. So in order to spoof the original device, I needed to use Xposed, but I couldn't use it because of the root detection. And finally, I had to use exactly the same phone, which was not rooted, but the data just copied, and I cloned the IMEI number, and it worked. Okay, so what can we do better to prevent this? Well, the obvious question would be, can we prevent the cloning? Well, unfortunately, we cannot prevent it at this time, but we can make it more difficult to exploit. We can use multiple countermeasures which would divert the attackers to the other target. In the simple words, just don't be the last one. So we can check for more device characteristics which are more difficult to spoof, for example. We can improve the root detections. Well, safety net is possible to bypass, but they are constantly improving, and they have ways to do it much better, to integrate deeper into the OS. There is a nice open source one which I found difficult to bypass. Well, of course, integrity protections that we wouldn't be able to patch the applications. Last but not least, I think the most important, the backend fraud management. At this moment, in most cases, they detect, for example, the duplicated card use. So this is the single-use card, single-use key. So when I use it twice, they lock the card. But as an attacker, I can make transactions before the original user, or I can lock the original user. So this duplicated card use will not appear. So I would suggest rather some kind of device scoring based, for example, what version of Android are you using and how is it probable that you are infected. There are malware handling solutions that are far from perfect and possible to bypass also, but you got to think of something, start with something. Well, in the future, of course, the devices will be more resilient. And I'm perfectly sure that Google is aware of its position, that with its great power comes great responsibility. And they work really hard to make the devices more secure. But on the other hand, the more widespread these mobile payments will be, the more they will get more attention from the fraudsters. Well, let's hope for the best, but I would suggest to prepare and verify for the worst. And with this optimistic accent, I just like to invite you for another talk at AppSecU, where I will be giving also a smart lock picking training. And I hope to see you tomorrow for blue picking, hacking Bluetooth smart locks. We'll have 7 different smart locks and a lot of fun. So I don't want to stand between you and the lunch. So you're free to go. And if you have any questions, I will be happy to answer.
Give a warm applause to Sławek. You ready to take some questions now?
Yeah, if we have time, yeah, sure.
I just served, but it isn't open yet. So any questions?
Thank you for the talk. Do you have any estimate what percentage of apps in the wild are vulnerable to your attack? And what is your estimate of the attacker effort in terms of time for this particular attack?
Well, as I said, we practically tested, practically proved on 8 applications the practical cloning, which is just a simple trick that doesn't need to, I don't need to decode the encryption, I just spoof the device and it works out of the box. And it should, in my opinion, work on all the applications based, like I told previously, on the libraries they use, because the same library works the same way. And all the applications that have this business requirement that it needs to work without user interaction, so user doesn't enter any PIN or whatever, and it also works offline, so you can't support the key from online something. So it makes this trick possible, in my opinion, on all the implementations. Well, you might be able to find better device characteristics, but I'm not aware of it. So the effort depends. The effort to attack depends on the specific application security countermeasures, like integrity protection, root detection, and what kind of device characteristics it checks. So if the root detection is really good, it's in native library and it's difficult to bypass, and at the same time the mobile application checks for multiple device characteristics that I can't, for example, just swap them in build.prop, and I need to use Xposed to spoof them, and then Xposed needs root, but I can't hide this root, then this effort would be much bigger because I would need to somehow fight with this, somehow bypass these countermeasures, or take exactly the same phone with the same IMEI number and then clone it. I hope it answers your question. Okay.
I'll go here first, and I'll come to you.
Thank you for your talk. And how different or similar is this to cloning contactless credit cards or debit cards?
It doesn't matter if it is a credit or debit card. It works the same, if that was the question.
Oh, yeah.
Hi, thank you for the talk. When you talked about the countermeasures, did you also consider, or do you see someone using the key store or the key store API?
Yeah, I saw the key store. Yes.
Especially in the newer version, I think it's bound to the hardware module, so you had better protection against cloning and rooting.
Well, I saw one implementation that used the key store, and the key store was just a file, in this case, on my device. So I just simply copied the key store content. I have root access, so I can also copy the key store file.
Yeah, but the key store itself is encrypted with the device pin.
Yeah, well, I was able to. Okay, it's encrypted in the device pin, but I assumed that as an attacker, I can also get the pin.
Okay. Yeah.
From the device.
Yeah. Okay.
Of course, I hope we will move more to TPMs or something, that we will be able to have a key store similar to the iOS has, and it would be really nice to have it in Android. But I know they are working on it, and I also told about it, mentioned it on my slide, and hopefully this will be one of the ways to improve the situation.
Okay. Yeah. Thank you.
Good question.
Does the CVM response include any sort of cryptographic verification, or is it another yes card style attack where the device just says, yes, the correct PIN was entered?
I don't know, because I am attacking it on a higher level. I mean, I just invoke the API call in the HCE library, and I don't care how it works on the NFC layer. So I assume that if there is some kind of crypto involved on the APDU packets on the NFC layer, the HCE library will take care of it for me. I just call it from the application layer, the method from the API.
So thanks for the call. My question was if any of the devices where you were able to clone the card emulation was using the hardware services of something like, I don't know, TrustZone?
You mean if the devices were using some hardware TPM or something like?
Or the secure world, if you like, that a TrustZone-like implementation would offer, so you could have the key store implemented there.
Yeah, well, I was doing my proof of concept on a device that doesn't have this key store. Like I previously mentioned, one of the applications used key store, but because the device didn't have hardware support for key store, it stored the key store in the file that, as a root, I could copy to another device. And if I set the same pin on another device, I can decrypt it.
Thanks for the talk. You've mentioned that in order for the contactless payment process to work, the screen on some devices needs to be on, right?
Yeah. Well, the screen on all the devices needs to be on. This is actually the requirement of HCE API in Android.
Okay.
But you can have additional, you can enforce additionally that the screen is unlocked, not just on.
Okay.
And that depends on the mobile application. So the Android API gives you 2 ways to do it. One way is the screen needs to be on, and it needs to be on physically because the NFC antenna is not wired up in other ways. And the mobile application can additionally enforce that the screen is also unlocked.
Okay.
But most of them do not.
In the case where just the screen, where the screen just needs to be on, does it work during, for instance, an incoming call or an incoming SMS message? Let's say you send like a class 0, class 5 message to the device, so it's silent, but still you manage to turn the screen on. And at that point, with a physical attack, you can just...
It's a really nice idea. Yeah.
So did you try any of that to see how the device behaves during that condition?
No, I didn't try. We can try it in a minute if you like.
Thanks.
I would just need to put the SIM card in. Yeah, well, we can try on my one. I have 5 different HCE cards in it, so.
What I suggest is, because lunch is opening in a minute, and again, if you have your T-shirts pre-ordered, please pick them up at lunch. Whoever wants to follow this demo, please join or ask them any questions after. I'd like to close this track for now. One more applause for Slawomir Jasek.
Thanks.